Imagine a device that acts as an artificial sun, capable of powering humanity with clean energy by holding together the hottest plasma in existence for over an hour. That is exactly what China's experimental advanced superconducting tokamak has just done, smashing its own world record by 10 times to hold steady-state fusion for 1,066 seconds at temperatures near 7 million degrees Celsius. This isn't just a lab curiosity. It is the most promising path we have ever seen toward an unlimited, carbon-free power source that could finally solve our energy crisis and climate problem all in one go. Today we break down exactly how this artificial sun works, why this specific record matters more than you think, and what it means for the future of civilization. Welcome back to the channel. Let's talk about the experimental advanced superconducting tokamak, or EAST for short. Situated in Shanghai, China, this machine is often called the artificial sun because its mission is to mimic the process that powers our actual sun and stars. For decades, scientists have been trying to replicate nuclear fusion on Earth. It's the holy grail of physics, but it's incredibly difficult because you need to heat atoms until they become a plasma so hot that nothing in the universe can contain them, except for magnetic fields. This is where tokamaks come in. They use powerful magnets to trap the superheated gas and prevent it from touching the walls of the reactor, which would instantly destroy the machine and stop the reaction. The breakthrough here comes down to stability. Fusion isn't just about hitting ignition. It's about keeping that fire burning steadily without crashing out. Previous records showed us we could get plasma hotter than ever before for short bursts, but those didn't last long enough to prove a practical energy cycle. China's EAST machine just shattered the bar by maintaining high confinement plasma for 1,066 seconds. That is nearly 17 minutes of uninterrupted fusion. This duration is critical because it proves that the magnetic confinement technology can hold the fuel steady long enough to be useful. It means we are finally moving past the phase of trying to make sparks and into the phase of making a flame that lasts. The temperature reached was close to 7 million degrees Celsius, which is 250,000 times hotter than the core of our sun, yet EAST kept it intact without melting down or losing control. Now let's talk about why this duration matters so much for turning fusion into electricity. Think about how nuclear fission works in current power plants. They burn fuel rods continuously, but they still need constant maintenance and produce radioactive waste that stays dangerous for millennia. Fusion is different because it uses isotopes of hydrogen, specifically deuterium and tritium, which are abundant in seawater and lithium respectively. The byproduct of fusion isn't toxic, long-lived waste. It's mostly helium, an inert gas you can just vent out into the atmosphere. But to make that difference real, we need a reactor that runs steadily day after day without needing to be shut down for repairs every few hours like current reactors do. The jump from 403 seconds in 2023 to over 1,000 seconds now is massive. It shows that the engineering problems of sustaining the plasma are being solved faster than anyone predicted. When you can keep the reaction going for this long at high confinement levels, it opens the door to building a continuous power cycle. Imagine a fusion plant that operates like a wind farm but doesn't depend on the weather and produces no carbon emissions whatsoever. The challenge remaining is scaling up EAST from its current size to something massive enough to generate gigawatts of power for a whole city or continent. However, the stability data provided by this record gives engineers the confidence they need to design larger magnets and better cooling systems that can handle the immense heat loads. We are no longer just dreaming about fusion. We have proven the core physics works in a sustained environment. The path from this lab in Shanghai to your local power grid is getting much shorter than it was 5 years ago. Let's dive deeper into what this means for the global energy landscape and why other nations are taking notice. China has been investing heavily in fusion research through its Institute of Plasma Physics, and this achievement puts them at the very forefront of a race that will define the next century. While countries like the United States with their National Ignition Facility and Europe with their ITER project have made incredible strides, EAST is showing us that steady-state operation is achievable on Earth. This is a game changer because many early fusion designs relied on pulsed methods where you fire up the reactor for seconds or minutes, wait for it to cool down, then fire again. That cycle requires complex, expensive systems and limits efficiency. The ability of East to run continuously means we can move toward a design that runs constantly, like a coal plant or a gas turbine, but with zero emissions. Critics might argue that fusion is still too far away for our current needs, pointing out the cost of building such massive machines. But look at the trajectory. If we have mastered holding plasma for over an hour, the next logical step is doubling that time and increasing the energy output to ensure the heat generated actually exceeds the power used to run the magnets. The Chinese team has already demonstrated this capability in previous runs, suggesting they are close to reaching ignition, where the fusion reaction produces more energy than it consumes. If we hit that mark with a steady-state machine, we could potentially reach net positive energy within a decade or two. This would allow nations to decarbonize their grids rapidly, ending reliance on coal and natural gas, which are depleting resources and major contributors to climate change. For developing nations, this technology could provide the reliable baseload power needed for growth without the environmental cost, leveling the playing field globally. So what should you take away from this? First, trust the science here. Fusion is not a lost cause. The stability record set by East proves that the physics works and the engineering hurdles are surmountable. Second, understand that fusion could be the ultimate solution to our energy security crisis, providing a clean source of power that doesn't run out and doesn't pollute. Third, keep an eye on China's role in this field. They are setting the pace for what is possible in terms of continuous operation, which suggests we might see more commercial demonstrations sooner than many experts expected. The practical implication is simple. Within a generation, it is very plausible that fusion power plants will be connected to our electrical grids. This means cheaper electricity, cleaner air, and a future where energy scarcity is history. The journey from the artificial sun in Shanghai to your home is real, and we are getting much closer than ever before. If you found this breakdown helpful, smash that like button and subscribe for more deep dives into the cutting edge of science and technology. Drop a comment below telling me if you think fusion will be the power source of tomorrow. Thanks for watching, and I'll see you in the next video.